If you're running large AI workloads, your infrastructure efficiency is really important. And the reality is most clusters are not designed for peak performance. That means you're wasting performance and time and money. One of the largest bottlenecks is data movement. GPUs are waiting around instead of computing. You're burning cache, and that is where rail-aligned architectures come in. RAAs are a way to design clusters where you're computing and you're networking and storage. They're aligned into these things that we call structured rails, and you can think of them as high-speed lanes for your data. In this architecture, instead of treating every node equally and sort of just hoping that the network is going to sort things out, these architectures intentionally group GPUs and storage in efficient paths, and it reduces congestion and makes sure that the data is always available sort of where it's needed, when it's needed. Most clusters are loosely coupled, which leads to efficiencies of GPUs wasting cycles waiting on data, and RAAs fix that problem. I can dive a little bit deeper and talk about what it actually means in practice. So let's talk about GPU utilization. So if you're training a large transformer model, the GPUs are constantly exchanging tensors with each other. But if they're connected across a slow or an overloaded network, some of these GPUs are going to be waiting while others work. They're going to be blocked, and this kills your overall efficiency. And so with rail-aligned architectures, the GPUs are connected using these high-speed lanes, which is not only the NVLink connecting multiple GPUs in a single machine, but through high-speed InfiniBand, and we've seen that increase utilization from 60 to 90% alone. Another example is pipeline parallelism. So if you're using a pipeline to break up which layers of a model are on different GPUs, if one has to wait for another, it's going to sort of stall out. Rail-aligned architectures can keep things flowing and keep your pipelines unblocked. So at scale, this saves real money, less wasted time, better ROI. To sum it all up, with rail-aligned architectures, GPUs are grouped into these high-speed rails with NVLink and InfiniBand connections, and the network traffic is intelligently managed to avoid cross-tier congestion. Fast local NVMe storage should also be present. It'll be optimized and prevent I/O bottlenecks. So when we've tested this against more baseline clusters, we've seen 30% higher GPU utilization, training times cut 20 to 40%, and ultimately it gives us more predictable performance at scale. Question that you need to ask is, does it matter for your workload? Well, if you're training models across a large number of GPUs, it absolutely matters. If you're running a smaller cluster with just a few nodes and GPUs with a well-designed network, it might not. You should run some tests. But if you're unsure, let's talk. I'm sort of obsessed about getting AI infrastructure right, and be happy to discuss it.